Can you tell me what impact AI, artificial intelligence, and let's also add machine learning is having on the industry?
If we don't develop new, more advanced, more performant technologies, the data centers will just explode. Since we can split up the chip into various chiplets, we can now make much bigger compute systems which you would not be able to make on one chip. They can do that by bringing together a lot of powerful chips and then connect them with these high bandwidth connections.
Hello and welcome to Connected, coming to you from SEMICON Taiwan 2024. I'm Divya Gopalan. There is so much talk about artificial intelligence and its advances, but it all comes back to semiconductors in the end. So we're here to cut through the buzz and meet the people and companies that drive innovation in the chip industry. Now, thousands of exhibitors and attendees have converged here in Taipei for this annual gathering of industry leaders. And we want to start off with an interview with one of them, Dr. Luc van den Hove. He is the president and CEO of imec. That's an organization on the cutting edge of nanoelectronic research and development, which brings together various industry players to cooperate on specific technologies. We started by asking him about the most significant industry changes he's seen since the pandemic.
Well, I think indeed COVID pandemic has created this awareness that chips are very strategic, because suddenly there were these supply chain challenges during pandemic, and in the context of the geopolitical tensions that are increasing, people start to realize, well, this is a pretty important risk. So as a result of that, each region has been setting up certain actions to ensure access to leading edge manufacturing, to strengthen leadership in terms of technology development. These are referred to in many regions as the CHIPS Act. And I think it's extremely important, and maybe we can talk more about that, it's extremely important that those actions will not decouple the world further, because our industry has been growing, has been so successful thanks to global collaboration.
Exactly. I want to talk a lot more about the CHIPS Act a little later in this interview, but let's go back to the fundamentals here. You've talked about the three pillars that have helped imec evolve, which is access to advanced infrastructure, a global ecosystem, and talent. Now, going forward, what do you think poses the greatest challenge for the semiconductor industry's advances?
Well, I think imec indeed has grown on those pillars, and we have been able to grow to become, well, it's probably the largest R&D organization in the world in our domain. And this is needed because the R&D challenges that are out there to keep the roadmap going. Many people have been saying Moore's law is dead. Well, we've been continuing for decades now. We're convinced we will continue for several more decades because we need it in order to address all these needs for like AI, for example. And imec has kind of set up a unique capability to, especially on the pre-competitive research, do that in partnership. So that's why bringing together this ecosystem has been essential to our success. But you can only do that if you bring the right talent together. So, and I think in the industry in general, talent is certainly one of the major challenges.
And if you had to pinpoint what is the challenge with talent, are we not seeing enough new talent come into the industry to meet the demand and the growth?
Yeah, I think it's a combination. I think it's a combination of not enough inflow of new people, because we should convince more people to start education in technology, to STEM directions, convince more women to go into this field. I think chips were not very well known, were considered as a commodity, and I think all the attraction was towards computer science now with AI burst. And so it's very important to understand that in order to enable all these innovations like AI, but also a lot of innovations in the healthcare system, the whole trend towards autonomous driving and stuff, it's all built on chip technology. It's the enabler.
So for a long time, a lot of the focus turned to software rather than hardware, but I'm really glad you brought up AI. Can you tell me, what impact AI, artificial intelligence, and let's also add machine learning is having on the industry?
Oh, the impact is huge. On the one hand, in terms of the market opportunity, AI, what happened over the last year, is really creating an enormous push and a demand for more compute power. And this is resulting in an enormous drive or a need for more advanced, more effective, more power effective technologies. Because if we don't develop new, more advanced, more performant technologies, I mean, the data centers will just explode, because if you have to handle all these AIs, you will have to grow the data centers, it will all consume more energy. So the only solution to that is develop more power efficient compute systems, so using more advanced technologies. So that's creating an enormous drive, enormous push to continue this roadmap, to continue Moore's law. So that's certainly the effect of AI, and we believe that we're just at the beginning. We're now talking a lot about generative AI in the cloud, but we're going to see an enormous trend towards massive AI deployment in automotive, the trend towards autonomous driving, in the healthcare sector, but also robotics sector. So I mean, we're just at the start here.
And that brings me back to another point you also mentioned about the use of power, being power efficient. How much of a concern is sustainability, given that this is an industry that really has a massive appetite for energy, power, resources, be it water?
Yeah. So sustainability is an extremely hot topic. On the one hand, we need more performant technology in order to address this energy consumption in data centers. That's the only way how we can keep it under control. So we need power efficient technologies. That's why we need this 2 nanometer and sub 2 nanometer technology generations. So the need is there, but in order to make those chips, those more performant chips, they will also consume more energy because the process flow becomes longer and longer. So we have to be careful that in order to solve the problem, that we don't create another problem in the fabrication of the chips. And so we have to have a very strong focus on how can we build those chips with a lower CO2 footprint. And for that we have set up a very important program also at imec, where we're bringing together the entire ecosystem, because this is not something one company can solve alone. We need to make assessments like, when we process these advanced chips, which steps are contributing the most to generating that CO2 footprint, and that can be different for one process flow versus another process flow. So already in the R&D, we have to take that into account when we select certain materials, when we select certain process flows, take into account the environmental impact of those decisions. But then when we know which are the bigger contributors, we can then work with the suppliers, with the equipment suppliers or material suppliers, to address some of these challenges and reduce overall the CO2 footprint of our industry. This is going to be extremely important to make it overall sustainable.
Yeah, as you said, this is a very carbon heavy industry, and you kind of touched on this, but I want to read a statement from your website saying that through our position, the semiconductor network, imec can provide both the knowledge and the insight needed to set the green conversion in motion. Are there any particular pathways that you feel that you've identified that can be put into motion right away?
Well, of course, on the one hand, one important thing is that a very important fraction of the overall CO2 footprint is generated by the electricity consumption, so we have to go to renewables for the energy usage. But then there are lots of materials that are being used in the process. Wastewater reduction is a very important one, so we have to take actions to reduce water consumption. And then there are many actions that need to be taken, like for example hydrogen reuse in the EUV scanner. So we work on all these individual process steps to address those items. But also PFAS is another very hot topic in terms of sustainability. We have to reduce the use of PFAS, and PFAS is being used in in many materials that are being used in the semiconductor industry, like photoresist or dry etch processes. We have to develop alternatives for those.
So moving forward, when it comes to the semiconductors and chips, the next big thing seems to be chiplets. Can you explain what those are and why that's seen as the next thing?
Well, we believe it's very important, and it's one of these elements that is going to be needed in order to extend Moore's law even further than what we could have imagined years ago. Because if you want to make these very complex systems, for many applications we have to build them up in a versatile way. I mean, a configuration for one application may not be ideal for another application. So what is being done is we split up the overall circuit into various sub-circuits, and because there has been so much progress in the way how we connect those chips with very high bandwidth connectivity, so you can actually create a performance by bringing together some of these chiplets that is very similar to if you would integrate everything on a single chip. Now, since we can split up the chip into various chiplets, we can now make much bigger compute systems which you would not be able to make on one chip. So like for AI, this has been very important to make these huge accelerators like NVIDIA is doing. They can do that by bringing together a lot of powerful chips and then connect them with these high bandwidth connections. But this is going to have applications in so many other domains also, like in automotive. We're setting up also a program to develop the compute system for automotive, also based on a chiplet concept, because what we can do then is what you typically need to do in such a configuration is bring together various processing units like a CPU, an accelerator, a neural engine, and for the car industry you will have to make configurations like some configurations for high-end cars, configurations for low-end cars, and by using chiplets you can combine those in a flexible way. So this is a very important technology that will actually allow one to continue this Moore's law, make very complex compute systems in the future. And we will see this through a combination of, on the one hand, scaling our technology to small dimensions so that we can put more transistors on a single chip, and then combining multiple chips using chiplets to make even bigger compute systems.
Right. So moving forward, I want to talk about imec's interest in startups. For one thing, why your as you said, your research and development, why is there this focus now on startups, you believe?
Well, imec has started mostly on the core technology, on chip technology, but gradually, and we were kind of driven by, I would say, a single roadmap, Moore's law. I mean, every 2 years we wanted to make our chips 70% smaller so you can double the number of transistors. Roadmap was pretty clear for decades. But now you see that it's not like just one roadmap anymore. We have to optimize our technology for various applications. Applications in AI, in healthcare, in automotive. They may require slight modifications of the technology. And so imec has gradually been stepping up in the value chain and start doing research also on the applications in order to understand what are the new requirements for applications to drive the chip technology. And the more we step into this application domain, the more we also see opportunities to create our own startups building on imec technology. So imec has a wide range of business models on how we work with industry. We can either partner with some of the big companies, we work with the suppliers, but we can also create our own companies, our startups, building on imec IP. And this is just another business model on how we bring technology into the market.
The startups that have the imec backing are very lucky to have imec behind them, given the resources that imec does provide. But in general, what are the biggest challenges for startups at this with this market, highly competitive market?
Usually startups that start from imec, they built on heavy technology and core technology. And this is typically something, it's a different kind of startup from a startup that starts working on an app, for example. I mean, a lot of startups start with 2 people in a garage and get going, whereas a startup that is more deep tech, hardware oriented, I mean, you need a big, a major infrastructure to develop your prototype, and that's where imec really can be very effective, because we have the most advanced pilot line, R&D pilot line in the world. And so one of the challenges for these startups is, of course, be able to make a prototype, and that's where our infrastructure can come in. Other challenges, of course, are to find the finances, because for these kind of startups, deep tech, you need pretty heavy rounds. And then, of course, find the team, build the team. So typically it's a combination of those aspects.
Right, so this brings me to something you mentioned earlier, the CHIPS Act. The US has its CHIPS Act, EU has its own CHIPS Act too, which is seen as quote unquote strategic autonomy, as they call it. But what it can translate to, and most likely translates to, sharing less technology. How much does that concern you?
No, that is of high concern, because I think the immediate reaction when there is this awareness of the challenges related to the shortage is, oh, we have to make sure we control it, and every region takes action to kind of try to do it all. I think this would be a major setback. This industry has grown so much on being interconnected, on building on collaboration, because if you want to be relevant in this industry, you have to have the critical mass. I mean, we're here in Taiwan, TSMC is the perfect example. You have to have critical mass in order to be relevant. So I don't believe in a model where every region is going to try to do everything. If that's the evolution, it would lead to a setback, and actually it would lead to mediocrity. So I think it's very important that each region strengthens its strengths and uses the CHIPS Act to strengthen the strengths, and then CHIPS Act should actually facilitate collaboration among the various regions in order to ensure the best possible progress for the technology, because the R&D challenges are incredible, are phenomenal. I mean, pushing the roadmap, I mean, we've been saying for decades it's going to be impossible, we will hit a wall. Well, we see a path for the next 20 years, but it's not going to be an easy path, so we better combine the best of the best in order to enable this roadmap to happen. That will be the only way to come up with sustainable solutions, to come up with real disruptive solutions. And so we should not try to do it all everywhere, but we have to strengthen our strengths and connect the strengths. I mean, here in Taiwan, it's the center of advanced manufacturing. I mean, in Europe, we have our strengths with unique equipment like ASML. We have imec as the world leading research center. We have some of the leading companies on chips for automotive, for sensors. The US has leading fabless companies and some top equipment suppliers. So I think it's very important to connect those strengths, because otherwise the progress in the industry may slow down, actually. So CHIPS Acts, I think, can be a fantastic opportunity to create the critical mass to move forward, but it has to be done right. We should not fall in the trap of protectionism.
Absolutely, it should not fall into protectionism. Unfortunately, we are seeing signs of that. And what is your biggest concern for imec itself as a neutral ground where people come and share their knowledge, if that happens?
Well, I think if the world would decouple, it would result in a slowdown of the innovation process. So that's my biggest concern. We are strongly advocating the opposite, and to basically use the CHIPS Act to facilitate some of the interactions across the continents. And we are very happy that, of course, we have been selected as a primary location for pilot line expansion in Europe on advanced technologies, but we're also, of course, interacting quite a bit with US CHIPS Act initiatives in Japan also. So I think that people start to realize that we need this strong connectivity between the initiatives.
Is there such a scenario as with all these governments, they're now creating their own semiconductor manufacturing industries? We're seeing it happen in India, Spain, just to name a few. Is there such a scenario where we'll get to a point where we have, at the moment, we have not enough supply and too much demand? Do you ever feel we'll get to a point where we have too much supply and not enough demand?
I don't think so, because the supply will adjust itself to the demand, I'm pretty sure. building a fab is a huge investment, and it's not going to happen if the demand is not there. On the other hand, I believe that the demand is going to increase tremendously over the next years, given all the new applications, given the demand from AI. But AI is just a start. I refer to healthcare, automotive, so many robotics, so many new applications. So there's going to be a huge demand, and I'm sure that build out of fab capacity will be synchronized with that increasing demand.
Right, and I want to bring it here to Taiwan. Taiwan's maintained its lead in advanced chips. Can you see that continuing?
Absolutely. I think that Taiwan has done a phenomenal job in building up that unique capability, and I believe that they will continue to be successful here locally. Because as I said before, you need critical mass in order to do that effectively. And this is a matter of scale. But at the same time, I also very much appreciate the fact that TSMC is also reaching out to other regions, to Japan, US, Europe, to also delocalize some of the manufacturing capability, because I think it's important for the world and to avoid the too high risk of having everything at one location. And I believe TSMC is doing it in a clever way. Like in Europe, I was present at the opening groundbreaking ceremony for the ESMC fab in Dresden, focusing on first step focusing on applications such as automotive, where there is a big need in Europe. Doing that in partnership with some of the European players like Bosch, Infineon, and XP. So I believe it's a very clever way to do that, and I'm extremely excited that TSMC took those decisions.
You're in Taipei, albeit for a very short period. Is there anything you're seeing here right now in the semiconductor space that is making you excited?
Well, I think all the vibe, the attention it gets, this is fantastic. I mean, this is such an important industry for Taiwan. Taiwan has done an incredible job in this. Who would have thought 40 years ago that TSMC would be the world leader? So yeah, no, I'm impressed with what is happening here, and everybody knows it. So I think the fact that there's so much buzz around this Semicon show, I think is fantastic.
Thank you so much. Thank you. And that was Dr. Luc van den Hove, the president and CEO of imec. As we've heard, carbon intensity and the drain on resources are two of the biggest challenges for the semiconductor industry. So we caught up with two startup companies at SEMICON and asked them how they're addressing environmental sustainability.
I think there's a lot of great minds, lots of great companies focused on this exact challenge in all areas of AI processing and transport of data. There's great work being done on data center models, compressing models, reducing the size, the footprint that models take in chips, and coming out with new mathematical models for neural networks. So there's a lot of work happening on the algorithm side to reduce the impact of compute. And then we're doing our bit too, coming out with new analog compute, neuromorphic type of approaches that are brain inspired to again, reimagine how neural networks are processed on semiconductors to again massively reduce the energy footprint. So a lot of great work happening. It takes time, however, right? As we talked earlier, it takes 3 to 5 years for a novel idea in the semiconductor world to see the light of day. So there's a little bit of a lag, but I'm very hopeful. I think with the talent and intelligence this industry has, we're going to see some great solutions emerge. It is absolutely core to what we're doing because all of us in the management team really saw this coming for a while. AI, the energy footprint of AI, if it's allowed to grow the way it is in this exponential manner, it is going to overwhelm humanity. So we really need to act on it, and it's really up to us because all of AI is run on chips today, and will be for a good number of years to come. So yeah, it's very central to what we're doing at Blumind.
Well, I mean, for everything that you're talking about, like whether it's AI or some of these high compute applications that everyone's talking about here, I don't think that the long-term future is going to be what everyone's describing here, because actually the energy that will be necessary to drive the solutions as is like astronomical. So actually, I think this is a starting point, and everyone has to drive towards greater sustainability when it comes to these solutions. So I would be hesitant to make like a declarative statement like we're leading this, charge, because I do think it's like early phases. Like if we wanted to really see an AI-driven world, like these chips will have to become really a lot more efficient. So Silicon Box is actually at the forefront of that. We really need to work on the energy intensity of these chips. Really the chips are driving the industry at this point. So if you're talking about sustainable development of AI, we're really at the starting point. We really need to make these chips a lot more sustainable. I do think chiplet architecture is a part of that, whether it's coming to manufacturing in and of itself or conceptually, you know what I mean? Because there's energy consumption within the chip and there's energy consumption to produce the chip. So Silicon Box is trying to be, efficient when it comes to the production of the chip, but also what we're trying to do is enable sustainable development of the chips themselves by making them more energy efficient. I do think in the long term, if you want AI to take over and be everything that everyone wants it to be, then we're going to need these chips to become a lot more efficient, far more than they are now. So I think we're only at the starting point when it comes to sustainability, and it hasn't really been the focal point for this industry. It's been more about advancements in tech, and I think those things have to converge now that the world is becoming about advancements in tech.
You will hear more from Niraj Mathur, the co-founder and COO of Blumind, and Mike Han, the head of business at SEMICON Box, as we continue our coverage of SEMICON Taiwan 2024. But for now, it's been great to have your company. If you've enjoyed today's episode or have anything you'd like to add to the dialogue, join the conversation on our social media. And remember, stay informed, stay engaged, and stay connected.